Hi everyone, I have a new version of Telemetry Viewer ready, and in this video I'm going to demonstrate some of its features with this very basic brushless DC motor controller that I've started to work on. Here I have a small brushless DC motor, the kind you might find in a model helicopter or airplane. It goes to a 3-phase half bridge. This one is much bigger than it needs to be, but I had it laying around. I monitor all 3 phase voltages and currents. To monitor the currents, I have 3 very small current sense amplifiers soldered onto what is basically a breakout board. That was a real pain to hand solder, but it works. All the signals go to a STM32F4 microcontroller, which is on the back side of this board. It talks to the computer over a USB UART. Here I have a USB hub with power switches for each port, which is very convenient. This is the 12-volt power supply for the gate drivers. It takes 5 volts from USB and bumps it up to 12. And like I mentioned, it's nice to have power switches for the ports because I can easily cut power to the gate driver or turn it back on. This is a USB oscilloscope and logic analyzer, although I'm not using it in this demonstration. Here's a lab power supply. I am feeding the motor square waves, not PWM, so I have a very low voltage of 2 volts right now. For visual feedback, I have a 4K webcam. On the bottom of the webcam, there's typical 1/4-20 threads for a tripod. I bought a separate ball head mount to make it easier to angle the camera. And then, of course, without a tripod, I just have it mounted on a long 1/4-20 bolt. To keep an eye on temperatures, I have a FLIR thermal camera. And that's basically it. So let's take a look at the new version of Telemetry Viewer, and I'll show you how it all works. I have the thermal image over here. You can kind of see the motor windings are kind of warm. And this area down here is the 12-volt gate driver power supply. We have the webcam view here. You can see the motor here, and then the in the background that lab power supply that provides 2 volts. This area will have the waveforms for the brushless DC motor. So like with earlier versions of Telemetry Viewer, you can transmit data to your UART. And so COM6 is the UART on my microcontroller. And I have it listening for commands to start the motor, stop the motor, spin it faster or slower. This is definitely not an example of a full-featured brushless DC motor controller. It is actually just the very basics, like first step you might do. It's just using a square wave. I'm not using PWM to generate like a trapezoidal waveform or a sinusoidal waveform. So I'm going to go ahead and start the motor and then adjust the speed until it stalls, because being open loop, if you try to spin it faster than it can support, it'll just stall. And then I'll stop the motor and I'll restart it and I'll slow the motor down, and we'll see how the current being supplied to the motor changes as you speed up or slow down when it's in a purely open loop control. So while the motor's running, I'm not going to talk because it'll be kind of hard to hear me over the noise of the motor. So let me go ahead and rewind, and I'll kind of explain what we just saw. So when it's starting to spin the motor, again, the entire time it's a open loop control. And so it starts off very slow and then ramps up to a steady speed. If we look, we can look at all 3 voltage waveforms. So you can kind of see how how they're in phase with, or how they're phased. The numbers down here at the bottom, 0 through 5, basically on the microcontroller, I have it send a enumeration telling it or indicating the current state of the motor control algorithm. And so with a brushless DC motor, you have 6 states that you step through as the motor spins. And that's what I have here. Basically, there are, well, it's a 3-bit number, but I'm not using 6 and 7. So 0 through 5 are the possible states, and I have it visualized as kind of like a logic analyzer would have like a waveform drawn. That's kind of what these indicate. So now they're all gone if you add them back. Another way to visualize a bit field, which again is just an enumeration or a Boolean value from your microcontroller or whatever. You could do it as a tooltip, where it would just draw a tooltip at the top wherever that event happens. Generally, a tooltip is more useful for a rare event. Like if this is a Boolean indicating a fault condition, a tooltip would kind of make sense. Since this is a repetitive thing, just showing the current level kind of makes more sense to draw it down here at the bottom. So if we continue, you can see that I had increased the motor speed. We can kind of see the waveform change gradually. And also you'll see the current draw is dropping because again, in open loop control, if the waveform is on for too long, if you slow it down, you'll see that it draws a lot of power because the phase is being driven much longer than it needs to be. And again, being open loop, you'll see that it draws 12 amps at 2 volts, so that's 24 watts. And you can see here the motor windings getting hot pretty quickly. Another maybe interesting way to look at the data. Okay, so I was just restoring the way the chart was. We're showing the voltage for phase A, the current for phase B, all of the states of the bit field from the microcontroller. And then I have triggering set to trigger on bit field state 0, which is the first step right there. If we look at the frequency content, so because I'm generating basically a square wave, there's a lot of harmonics. So the fundamental is right around here, which looks like about 280 hertz. And then if I play the waveform, as I adjust the speed of the motor, you can kind of see how the frequency content changes. Let me go back though. So whenever you have varying frequency content over time, instead of looking at individual Fourier transforms, it can be useful to look at a waterfall view. Let's try this. And so now you can see the harmonics. And then as I adjust the speed, you'll see them drift all kind of in unison. Anyway, so yeah, that's kind of an interesting way to look at the data. Some of the new features that I've added to this version of Telemetry Viewer. Previously, I was using a webcam library that had some bugs and it didn't really have a lot of features. I ended up writing my own webcam library, and so now you can actually adjust a lot of settings for the cameras. So if I go back to the live view, go to the end. For example, if I look at just the webcam, my webcam happens to be the OBSBot Meet 2. And it has a bunch of settings you can change. So for example, I can adjust the digital zoom. It'll let you adjust the exposure, which seems to be shutter speed. You can kind of see, if you look down here, you can see the 7-segment LEDs flickering because of the way that the shutter interacts with that. On this camera, gain doesn't do anything unless you have exposure set to manual. And it looks like gain is basically a post-processing. And if you take it to the extreme, you can kind of see clipping. Whereas the exposure setting would be, more analog. Other webcams that I've tried, the gain and exposure work a little bit differently. So you kind of have to play with your camera and see how it performs. I've also found some cameras are kind of buggy where, like on this camera, like if you zoom in, you can use pan and tilt to basically shift where it cropped in on the image. So you can go left and right, and that's good, that makes sense. But if you use both pan and tilt at the same time, it kind of it'll undo the pan, and then, yeah, see, like it'll tilt. So it's kind of weird how you would think that it would keep both. Yeah, see, like, yeah, kind of weird. Anyway, that's basically up to however the webcam implements things, so I don't have any control over that. For these things that have a checkbox, if it's unchecked, it'll be automatic. So right now we're on autofocus, and if you check it, it'll be manual control. So now I can manually focus on, like for example, now I can focus here or up close. As I mentioned at the beginning of the video, this camera can do 4K. I hope my laptop isn't going to struggle too much doing the screen capture and also this at the same time, but let's find out. All right, that seems to work okay. So now we can see it's doing a 4K capture, a little bit better picture quality. At 4K, it'll only do 30 hertz. One of the interesting things about this webcam is if you do like 1080p at, earlier we're doing at 60 FPS, but if you do it at 30, if you zoom in, it'll actually retain a pretty good picture quality because it'll basically use a different region of the image sensor. So you can zoom in and it'll be, you know, pretty high quality. Whereas if you do it at 1080p 60, it's purely a digital zoom. And so it'll get very pixelated pretty quickly. Yeah, so you can kind of tell the difference there. On the FLIR camera, the gain seems to have no effect. Doesn't really do anything, as far as I can tell. Same with focus. Supposedly it supports manual and autofocus, but I don't know why it does that because it's a fixed focus. It does have a digital zoom, which is kind of interesting. It doesn't really give you a whole lot more detail, but it's a digital zoom, which I guess could be a little bit useful. Anyway, so yeah, if you have different webcams, just play with the adjustments if you want. They might work, they might not. It depends on the camera. Another new feature that I added to Telemetry Viewer version 0.9 is it can automatically detect when a connection is lost, and if that connection fails, it will try to automatically reconnect. So, for example, let's see, if I go to auto. So we can see here the microcontroller is sending data. It's, you know, jumping around, but don't worry about that. If I reset the microcontroller, the COM port will fail. And I have it configured to try to automatically reconnect. And so you can kind of see down here, it will periodically try to reconnect. And if I reconnect the microcontroller, it'll automatically reconnect. So that can be really useful if you're like developing firmware on your microcontroller. Whenever you reset the microcontroller or whenever you reprogram the flash, obviously your connection will drop out if it's a USB UART because the USB isn't going to function when you're resetting the microcontroller. If for some reason you don't want it to try to automatically reconnect, you can just uncheck this. And then it won't try to reconnect. It will tell you that the device was lost, and then if I reconnect it, it'll also tell you the device was found, and it's up to you if you want to reconnect now. And there you have it. And so we also just kind of saw that it'll now tell you about new devices. So that can be really useful because, for example, here I have 4 different COM ports on my computer. And what if you don't know which one is the device you're trying to talk to? So you can unplug a cable, plug it back in, and you'll be like, oh, okay, it was that COM port. So, for example, so if I plug in another USB UART adapter, looks like it's COM 8. And so then I could go down here and pick COM 8 and then connect to it and do whatever I need to do. Previously, in older versions of Telemetry Viewer, you had to close Telemetry Viewer and reopen it in order to see new devices, whereas now you can just plug them in whenever you want and it should just work. Kind of a small thing, but it took a lot of work to get that to work reliably. Maybe the most convenient new feature I've done is I was able to package up Telemetry Viewer as a fully contained exe file. So now it's a single file. You don't need to have Java installed. You don't need to have the right version of Java or anything like that. It's all fully self-contained. You just download the file, double-click it, and it'll open up. I also packaged it for Linux, and then also the ARM version of Linux, which would be usually like the Raspberry Pi. Another new feature is previously for the sample rate, you had to type in a number, whereas now it'll default to automatically calculating the number of packets that are received per second. So you can see here, my microcontroller sending approximately 44,000 telemetry packets per second. If you know exactly what it should be, you can type in a number. So if I know that it's going to send, let's say, 1,000, you can just type in 1,000. If you want to go back to automatic calculations, you can just type in 0 and press enter. It'll go back to automatic. The sample rate is kind of important if you're going to look at any of the frequency domain charts, because that will determine the the frequency range that corresponds to what the data you're sending. Other changes you might have noticed. So I changed kind of how the widgets are laid out. I tried to make it a little more compact and easier to understand. Another change you may have noticed compared to earlier versions is I tried to make the user interface a little more intuitive. So for example, now the text fields, they usually have a label and then a unit if it's appropriate, or if you're adjusting a chart. I kind of have things more organized now, so I have all the x-axis stuff in one area, all the y-axis stuff in another area, trigger stuff in another area. Should make it a little bit easier to understand and a little more compact at the same time. I used to have a setting called, I think it was benchmarking mode or show benchmarks. I relabeled it to show CPU and GPU usage because that's kind of more obvious of what it does. You can see here that I'm doing about 240 frames per second. I'm on a monitor that does 4K at 240. So I know this screen capture may only look like 60 FPS, but my computer is actually able to do 240, which is not bad for a 4-year-old laptop. So I've got an RTX 3060 with an i9. Most of the load is just from the screen capture, but this part is really drawing less than half of available power. Another feature that I added was the ability to limit the frames per second. So especially if you're on a laptop, it can draw a lot of power. Let's see if I make this always on top. So right now I'm drawing 240 FPS. If I limit it to 60, I can see a difference, but you guys probably can't because of the screen recording. But you can see that now it's using much less of the GPU. You can also drop it down to much less. You can do 10 FPS and use even less of your GPU and a little bit less of your CPU. So that can be really useful if you're on a laptop and you don't want to have it get too hot, or if you've got a short battery life. Set it to 0. We'll return to a unlimited frame rate. So I've always had the ability to export your data. If you click export, you can pick whatever you want. One of the new things I added though is if you just save it as, just call it default. So DEFAULT, all lowercase. And if you save that in the same folder as the Telemetry Viewer file, so your exe or the run file if you're on Linux, just save it, just save it in that same folder. All right, so that took a while to export because it was a lot of data. But if I now close the program, it saved the 4 files right here. So that's the settings file. We have the CSV file from the telemetry from the microcontroller, a little over 5 gigs. The thermal imaging video was about 200 megs. and then the webcam video was about 20 gigs, pretty big. But yeah, so if you label it as default and you put it in the same folder as Telemetry Viewer, when you open Telemetry Viewer, it'll automatically import your data. And so this is the recorded data that I had captured earlier. Like before, by default, it'll import it kind of in real time. And if you want to just import everything and then be able to look at it and rewind, you can click Finish, and it will import it as fast as your CPU can parse everything. And then at the end, you can rewind and look at whatever data you're interested in. So you can kind of see this is where we were talking about the webcam settings and everything like that. And then yeah, so now you can click and drag to find whatever you're looking for, like that, for example. If you don't want to import all of your data, but you just want to reconnect to your devices, all you need to do is export the settings file as default.txt. You don't have to export the actual data. So if I delete those. So now when I open Telemetry Viewer, it'll try to reconnect to the devices instead of importing the old data. And so here we are, we're back to the live data. So yeah, like if you just want to be able to have it reconnect automatically, just export your settings file. You don't have to export all the other stuff. So I went ahead and just restored those files so we can look at the saved data. So now looking at the old exported data, you may have already noticed one of the features I added was if you hover over the timeline, it'll show previews of any webcam images that you have. So for example, we can see here that this is where I was talking about the webcam settings and adjusting like the zoom and pan and tilt and all that kind of stuff. Of course, you can also just click and drag if you want to jump to that point and see it over here. Another feature that could be useful in some cases, let me go back to where the motor is running. I added the ability to show units on the axis labels or tick mark labels. So previously it would just show 0, 1, 2, 3, and then you could have it say volts for the unit. But I was able to have it kind of try to intelligently figure out what the unit should be. So if your unit is volts, it'll show V. If it's amps, it'll show A, that kind of thing. If you like to have the axis title like before, you can go to titled, and then it'll show the axis label. Same for here, it'll show sample number. But by now it defaults to just showing the number with the unit, because I think that's usually pretty obvious what you're doing. And then sometimes, especially if you have a lot of charts on screen, you may want to have more space for the plot. And so I added I called it an inner mode, maybe better to call it maybe compact, I'm not sure, where it'll show the numbers on the inside of the chart, which can be useful if you don't have a lot of space. So stuff like that. And you can also have the legends being drawn inside the chart as well. And so now much more of the tile, almost the entire tile, is dedicated to the plot. In this case, I only have 2 plots on screen, so it's not a big deal. But if you have, a dozen or more, that can be really helpful. In previous versions of Telemetry Viewer, you could change the display scaling factor by, if you have your mouse over the charts, hold down Shift and scroll. It'll make everything kind of bigger. That's useful if you're going to be maybe like across the room and you want to be able to glance over at your computer and see what's going on. Like you could maximize one chart, and then from across the room you could see this and read it, figure out what's going on. You can go even bigger if you want. But I added a widget to do that here. So the scaling factor slider does the same thing. So now you don't have to use a keyboard shortcut, but you can if you want to. Also, because it is now a setting in this region, if you export your settings to a file, it will save that scaling factor. And when you import it again, it'll restore whatever factor you chose. Also, if you used the triggering functionality like I am in this video, before triggering would only work if you were watching or if you were showing like a live view, if you weren't like rewinding or paused. Now triggering works always. So you can be rewinding, you can play backwards, you can play forwards, you can pause, and triggering will still work. So that can be really helpful if you use the trigger functionality. I'm not sure if I mentioned it earlier, but now you can trigger on bit field. So previously you can only trigger on a regular telemetry data set, like a voltage or a current or whatever. But now you can have it trigger on a bit field, so a Boolean or an enumeration. In this case, if you trigger on the rising edge of enumeration 0, whenever it transitions to 0, it will consider that the trigger point, which you can kind of see there. Another minor change is previously for the bit field icons, to select them, I used some Unicode characters to try to indicate what they do, but that wasn't really intuitive, which is why I now draw these icons. So that there's a tooltip icon to draw it as a tooltip, or there's the kind of logic analyzer icon if you want to draw it as a bar down at the bottom. If we look at the frequency domain charts, temporarily I'm going to go back to a regular single FFT. I added a feature to where auto scaling can ignore the outliers. Previously it would not ignore any outliers, and so you'd end up with a lot of space at the top and the bottom, because if you had like a little bit of data that drops down really low or jumps up really high, usually you want to kind of ignore any of like a small percentage of the really extreme values. And so I think before it was 0.5%, you can go higher. Usually 0.5% to 1% is good enough. It's particularly useful if you do, let me go to demo mode. So it's particularly useful like here, where you have like just a really small amount of data that drops down to basically 0, and that causes the auto scaling to not really show you the data you probably care about. And so again, this is kind of why, like, if you have it ignore the top and bottom 0.5%, it'll show you more of the data that you probably actually care about. And then going back to the imported data, so looking back at the frequency domain chart here. So in the histogram mode, now you can specify the number of bins for both the X and Y axis. You can also have it calculate them automatically. So if you choose auto, it'll try to make the bins approximately 2 pixels wide, which could be good or bad, because whenever you have a histogram, you got to think carefully about your bin size, because if you make the bin really small, then you'll have very little data in each bin. So for example, if I maximize that chart, it's now really kind of hard to see a lot of detail. Whereas if you drop the bin count down, you can kind of get a better idea of where all the data is actually, occurring. I also added I'm not really sure what to call it. I call it a gamma curve, but maybe that's not the best word. But if you've used an oscilloscope or a spectrum analyzer, they usually have a way where you can kind of show the details a little more, like the events that occur very infrequently. You can have it kind of emphasize that. So a gamma of 1 will give it kind of a very linear, I guess, color grading or whatever you want to call it. And if you want to see any outliers or rare events, you might go down to, like, say, 1/2 or less. And that also applies to waterfall mode. You can also choose the gamma for that. And the ignoring outliers is also really helpful for waterfall mode, because otherwise it can be kind of hard to see the details. It'll, when it auto scales and actually shows every single outlier, your data will be in a more narrow band of the color gradient, or whatever you want to call it. So the more you ignore, I guess you could say the higher the contrast you would get in the image. There was also a lot of effort on improving performance. In a lot of areas, it should be a little bit faster than before. Importing, exporting, histogram charts, frequency domain charts, webcams, they should all be a little bit faster. The display scaling is much faster. So like I mentioned earlier, previously you had to use a keyboard shortcut to do this basically, and it would be really slow. It might take like 5 or 10 seconds to change between 1 or 2 values because I have to regenerate the font texture for OpenGL every time you change the scaling factor. And it used to be really inefficient. I was able to improve that, and so now usually within like a fraction of a second it can change the scaling factor. Also, something I can kind of show is if you have a lot of data on screen, let's say maybe 6,000. If you show a bit field event as a tooltip, you can end up with a lot. And now they all draw at the top, which is kind of more intuitive. Before, they would kind of, instead of overlapping, they would try to like draw one here, and they would pop down and draw one here, and pop down and draw one here, and it was really not very intuitive, not easy to understand. And so if you do something ridiculous like that by accident, now you have a whole bunch of overlapping up here, and if you just, well, turn off tooltips. If you move your mouse over it, it'll bring the one closest to your mouse to the top so you can read that bit field tooltip. It's now rendering much faster. Like you can see here for the level visualizations, even though we have thousands of them down here, it's not slowing down. I'm still rendering at 140 FPS on a laptop. Not too bad. Oh, and I almost forgot to mention there was one other significant feature I added. So if I remove... So you might have seen in my earlier videos, I was using my smartphone as a network camera. So I'm connected to my smartphone and streaming a video stream over Wi-Fi. And previously, the Android app that I use has always had features for adjusting camera settings, but I never exposed it in Telemetry Viewer. And as you can see here, I've added the ability to adjust some of the probably the more popular settings. So, for example, JPEG quality, you could lower it if you want. If you want to save bandwidth, you can see it gets, kind of ugly, but that can be useful if you're on a poor Wi-Fi connection. Be careful if you drag it too high, because you can see here with it kind of near medium quality, I'm using almost 100 megabits just for the camera stream. You can switch between front and rear cameras now. You can turn the light, your smartphone's flash. You can turn that on or off. You can zoom. And so my phone has multiple cameras like a lot of modern phones do. So it'll switch between the different, like the 1x camera, the 3x camera, the 10x camera. For focus, you can have it autofocus. Smooth is a slower focus where, let's see if maybe I can demonstrate it. Maybe here. So that's a relatively smooth autofocus that's good for general use. If you want a faster autofocus, if you have it focused where you want, you can lock it there so it doesn't change. And now it won't autofocus, it'll stay where it was. And of course you can do manual focus. All right, that was basically the last significant change that I added. I was editing this video and realized I forgot to mention a few of the new features. So previously with webcams, there were only 4 resolutions you could pick from, and it would try to find the closest match when you connected to the camera. But with my new webcam library, I was able to figure out the supported resolutions, frame rates, and codecs. So now you have a specific list of what your camera can support. So different cameras support different options. And then another thing to keep in mind is if you have a high resolution or high frame rate webcam, If it supports a MJPG, motion JPEG format, that'll be a little more efficient. The YUY2 codec will use a little more CPU load, but if you have a high resolution and it shows both MJPG and YUY2, the MJPG option is much better. I recommend you pick that option. Another new feature is if you try to create a connection, and let's say we'll just... so previously I had it generate example code, but it wasn't for every single possibility, whereas now I'm able to generate code for every telemetry connection type. So if it's a UART in either CSV mode or binary mode, or also for TCP mode or UDP mode, I now generate example code for all of them. There will be example code for the Arduino and ESP32, which would be example firmware for how to send telemetry to the computer. And I also have example Java code, which would be how you could write a custom utility to transmit telemetry to your computer. So, for example, if you're getting data from some device that doesn't format the telemetry in a way that Telemetry Viewer can process, if you're a software developer, you could write a little Java program that obtains the telemetry using whatever API or data format it requires, and then you can then translate that into a format that Telemetry Viewer can interpret. And so again, it'll now generate that for every type. So if you do like a binary, let's say we have 4 data sets, and then maybe you have a checksum. It'll even show you how to generate the checksum. So for example, there it's generating the checksum and then putting it in the buffer. So that should clear up a lot of misunderstanding about how to generate data. And of course, if you're using the binary mode, the theory is you would have this match whatever data structure your microcontroller is actually using. That way your microcontroller can much more efficiently send the data. In theory, you could just do a mem copy of a struct and then transmit that instead of having to populate a buffer byte by byte. However, I show how to do it that way just for clarity. And then another possibly useful feature for some people is if you are using the TCP or UDP modes, you can now transmit as well. So if you go to the Settings tab, you now have the ability to transmit to UDP or TCP as well. The way it works is you have to have a connection active in order for it to transmit. I know that with UDP, it's not really connection-based, but it's just the way that Telemetry Viewer is kind of architected. The thread that does the transmitting is kind of associated with a connected connection. But for example, what we can do is we can use Telemetry Viewer to transmit telemetry to Telemetry Viewer. You can transmit to localhost. In this case, we'll transmit to the same port. So port 8080 is the port that we are listening on. And let's just say values of 1, 2, and 3 for those 3 data sets, and we'll end it in a new line and line feed. Transmit. And so if I create a chart, if I transmit again, oh, here, let's make it, there you go. I think I had scrolled my scroll wheel, which yeah, that's why. Go back to the end. And so now you can see it showing the data. And we can save that here. And let's say we do 2, 3, 4. We can transmit that. We can save it. Anyway, so you get the idea. You wouldn't really need to do this, but now yeah, you can transmit TCP or UDP data. Like before, you can do it as text, hex, or binary data. You can have it automatically repeat. So let's say we do 5, 6, 7. Have it repeat once a second. And there you go. If you have a typo, like if your host name or IP address is wrong, you'll get a notification. So that'll get pretty annoying. If you want to be really annoying, you can have it do it a lot. Anyway, that's kind of ridiculous. Anyway, you get the idea. You can now transmit data. All right, hope you enjoyed the new features that I've added to Telemetry Viewer. I'll put a link in the video description to the download page and all the details. Like before, there's also a link to a PayPal website if you find the software useful and want to send a few dollars my way. It would really encourage me to keep doing more and more. If you have any questions or comments, please leave them down below. If you know anybody that would benefit from this video, please share a link with them. So that's pretty much it. For any software developers, I'm going to include a little more information at the end of this video. I've made a bunch of changes in order to package everything up for Windows and Linux. So I'm going to include a short screen capture video of how to set up your software development environment for anybody that is a software developer. If you're just a regular user, you can ignore the rest of this video, and I hope you enjoyed it. All right, so if you're still watching, I assume you're a software developer. If you go to the website, download the source code package. So if you open the zip file, you can extract it wherever. Put it on the desktop for now. So if you go to the root folder of the project, there's a build.xml file. Open that up. So this is the Ant build file, but the reason I recommend you open it up is it has information on how to set up a development environment. So basically, as a brief summary, I developed Telemetry Viewer in Windows 11 with Eclipse, the Ant build system, and then Java 25. I assume you already have Windows installed. Let's install Java 25. So we go back to the downloads folder, run the Java 25 installer. So the Java installer will put java.exe on your path, but there's other utilities like JDEPS and JLink that we need, and they are not on your path by default. So if you go to start, type in environment variables, usually just env is enough. Go here. Go to environment variables, go down to system variables, go to path, edit, and then before we go to that, we need to copy the path to the bin folder. All right, so we can click new, and then paste with Control V, and then OK, OK, OK. We can verify that worked right, so we go to open up CMD. Let's type in JDEPS. Good. So it ran the program. That confirmed that our path variable has been correctly updated. I already showed you how to download the source code, the zip file. Let's install the Eclipse IDE. So you can use the Eclipse installer, Windows, download, open the installer. And in case it isn't obvious, so I'm doing this in a VM just so I can show you the whole process, but there's no need to do this in a VM. You can do it on your regular computer. Anyway, so yeah, you go to Eclipse IDE for Java developers. For the Java VM, we already installed one, so we can pick it. We can just go down to JDK 25, and the other options are fine. Go to install, accept. And then you can go to launch. So the first time you run Eclipse, it'll ask you where you want to have your workspace. The default option is fine. You can put it somewhere else if you have a preference. And then you can check to use that as the default. Go to launch. You can close the welcome tab. You can close the nag screen they popped up. So we can now import the Telemetry Viewer source code. So we'll go to Import, General, Existing Projects. So Import, General, Existing Projects. Next, it's in an archive file. So go ahead and browse to the .zip file you downloaded. You only need the second one. So when I set up my Git repo, I think I accidentally created the Git repo like one folder above where it should be. So I need to fix that eventually. But you only need the second one. Otherwise, you'll end up with basically 2 copies of the project over here. And click Finish. All right. So project is over here. All of the code is in the source folder. I'm not currently using any packages, so everything's in the default package. And we can open up the build file here now. All right, we can close Notepad now. We don't need that. You could start by opening up the main class. So go to double-click main.java. And then before you can run it, we need to create a run configuration. So you can use the toolbar and either go here, or you can go to Run and Run Configurations. Go to Java Application, double-click that. If you go to the Arguments tab, there's a bunch of arguments you need to add. Okay, never mind. So I guess we do need to keep that notepad open. So you can copy and paste these. So in the ant build file, this is all technically one giant XML comment, and I can't put 2 hyphens inside of an XML comment because that would, violate the XML requirements. So whenever you see 2 of these, tilde, replace those with 2 hyphens, and get rid of the extra white space. So basically, the way Java works is in modern versions of Java, if you want to call native code, in other words, like C or C++ libraries, you have to enable native access. I need to do that for, well, pretty much everything, for OpenGL, for webcams, that kind of stuff. And then the OpenGL library that I use has to interact with parts of the Java developer kit. So we need to open access to a few different parts of. And if you click Run, it should work. And yeah. So this is a bug in VMware. But let me explain that. So if you disable anti-aliasing, you'll now see that the text rendering works and everything's fine. So you go to VM, Settings. If you go to Display, when you use the accelerated 3D graphics, driver, there seems to be a bug in VMware where it doesn't render some of the text in OpenGL, and when I use a Linux VM, it also kind of flickers in the charts region. I get some weird flickering in there. I found that if I uncheck Accelerate 3D Graphics, it always works perfectly. I also found that it always works perfectly in VirtualBox, which is another VM program. And it also seems to always work perfectly on physical computers. So I'm pretty sure this is a bug in the VMware accelerated GPU driver. But if anybody has any other information, I'd love to know. But anyway, so if you use the accelerated, what's it called? Yeah, Accelerate 3D Graphics. In a VM, you'll need to disable anti-aliasing, and then it'll work correctly. If you want to use anti-aliasing, then you have to uncheck that Accelerate checkbox. So yeah, now Telemetry Viewer is working, and you can modify the code, do whatever you want. So you could, and then click play again. Always save before launching. And there you go. You can see your change. So if we go back to the build file, so it'll show the build targets here if I have the build file open, but I like to have a separate tab so that even if I'm looking at the source code, I can see the Ant build targets. So if you go to Window, Show View, Ant, it'll create a tab here. I like to kind of drag it down and put it. So I like to have the Ant tab here, so it's pretty much always visible. Click the plus Ant icon, and then go to build.xml. Now you always have the build targets listed. As part of the source code zip file, I don't include all the tools because I'm not sure if I have the legal permission to redistribute some of them. So the build file has a script that will download all the tools for you. So if you double click download tools, it'll start downloading a bunch of stuff. It might take about a minute. So if you're curious what it's downloading, if we scroll down, so it's going to download this stuff. So it's downloading Java 25 for Windows, for Linux, and for Raspberry Pi. It's downloading JExtract, which you probably don't need, but if you end up modifying the Webcam library that I wrote, JExtract is used to generate the Java bindings. 7ZR is the command line version of 7-zip, and I use that to do some of the archive work. 7ZSFX is the self-expanding archive utility that I use to make the .exe for Windows. Basically, the exe is an archive file, and when you double-click it, it extracts it to a temporary folder and then runs Telemetry Viewer. And then for Linux, I use a tool called make_self, which makes a self-expanding archive. And then on Windows, by default, the exe will have an icon for 7-zip, and it will have some version information also for 7-zip. And so I use a free utility called Resource Hacker to remove the default icon and version information. Anyway, we can see here that it successfully downloaded all the tools. And at this point, I'm assuming you only want to build it for Windows. You can just double-click Build Windows x64. While that's doing its thing, I can explain that as well. So here's the target definition over here. I create a temporary folder. I then call another target called build jar, which is this one down here. That will package, or that will compile all the Java code and then package it into a single, what they call a fat jar file. I use a tool called JDEPS, which looks at all the Java code and figures out what portions of the Java development kit are required. And then I use a tool called JLink to create a Java runtime environment that only includes the required parts. That saves a lot of space. I then use the 7ZR tool, the command line version of 7-zip, to package all of that into a .7z file. So it takes the JRE that we generated, it takes the fat jar we generated, and it also takes any of the DLLs in the lib folder and packages all of that into a telemetry viewer.7z file. I'm using the LZMA compression algorithm. If you don't want to compress, you can replace that with copy, and you'll have a larger exe, but it'll also open up a little bit faster. There is a script file that you use to configure 7ZSFX to tell it what you want it to do. Basically, hidcon means hide console. In other words, don't show the command line window. And then I have it invoke a command where it will cd into the directory of the exe file, and then it will call Java with a command line argument and then the jar file. And the reason why I have to cd is I want the working directory to be the same directory as the exe. That way, for example, if the user saves a default.txt file there, it can find it and automatically import it when you run the program. There's more information here as far as what all of this does. You can read here, and then I have some more information here if you care about all the about all the details. Finally, I take the 7-zip SFX file, and then I concatenate that with the this config file that we just created, and then the 7z file that we created earlier. And that all gets concatenated into a single file, which is the exe. And then to remove the default icon and version information, I use the Resource Hacker tool, and I have it delete the icon and delete the version information. And that's basically it. Then I remove the temporary files, and you're all done. So you should end with build successful. And then if we go to the location of the project, so it should be under C, users, whatever your username is, and then Eclipse Workspace, Telemetry Viewer, and there's your exe. So I mean, you can run it here if you want, or you can, you know, put it on your desktop or wherever you want it. And you're pretty much ready to go. So you could give this to a user. If they double click it, it extracts. And there's your modified Telemetry Viewer. And again, this is only an issue in VMware, but on a regular computer, it should work correctly. So I think most people only really care about those two targets. You only need to download the tools one time. After that, they'll stay in your project folder, so you don't need to call it again. Just call build Windows whenever you want to generate a new exe. If you want to create versions for Linux and ARM Linux for the Raspberry Pi, you'll need to do a few more things. You'll need to install WSL1, and I have all the details here and some more information. If you want to modify the in the project folder, if you go to the lib folder, I have the source code for my webcam library here. If you ever decide you want to modify the C++ code, you'll need to install Visual Studio 2022 Community Edition, and then after you modify any of that code, you'll need to run the compile webcam and generate bindings target, which will compile it into another DLL, copy it into the project folder, and then regenerate the Java bindings. Before you distribute copies of Telemetry Viewer, it's usually a good idea to test it on fresh installs of Windows and Linux. That kind of helps to make sure that you're not accidentally depending on anything that's, you know, on your development computer. So what I usually do is I'll set up VMs, which is why I have, you know, Windows 10, 11, and a couple versions of Linux. And I'll save a snapshot after a fresh install, and then I can copy Telemetry Viewer into those VMs and make sure everything works correctly. To automate that, I have these run targets to use SSH to copy the exe or run file to the VM and then run the program. And then if you're developing software, sometimes you make a mistake and the program might lock up, or it might be slow to respond. In that case, I have these terminate targets, which can, again using SSH, force close Telemetry Viewer and then delete any temporary files that might have left. And then I also test on a Raspberry Pi, and so I have a little script to shut down the Raspberry Pi when I'm done. Yeah, so that's basically it. Feel free to read more of the comments and the rest of the file. If you want to do all of those VMs and Raspberry Pi testing, you can set up your own VMs and then just adjust the host name and usernames to match, you know, whatever you're doing. I use public keys for secure shell, so you'll want to generate your own public and private key and then replace this path with the path to your private key. So that should get you going. Everything's really heavily commented, so it should be pretty obvious what's going on. If you have any questions or comments, leave them down below.